Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on L'Hopital's rule is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be discussing the indeterminate form 0 over 0, the indeterminate form infinity over infinity, and related indeterminate forms. L'Hopital's rule, named for the French mathematician Guillaume L'Hopital, allows for the evaluation of limits in the indeterminate form. For example, let's look at the following limit. The limit of x cubed minus 2x plus 1 over x minus 1 as x approaches 1. Using substitution, we arrive at 0 over 0, which is indeterminate. Suppose f and g are differentiable on an open interval L containing a, with g prime of x not equal to 0 on L when x is not equal to a. If both the limit of f of x as x approaches a and the limit of g of x as x approaches a equals 0, then the limit of f of x over g of x as x approaches a equals the limit of f prime of x over g prime of x as x approaches a. To prove the special case, where the indeterminate form is 0 over 0, we assume f prime and g prime are continuous at a, f of a equals g of a, which equals 0, and g prime of a is not equal to 0. We start with the simple idea of a limit. The limit of f prime of x over g prime of x as x approaches a equals f prime of a over g prime of a. Then we use a definition of a limit, so that the limit of f of x minus f of a over x minus a all over the limit of g of x minus g of a over x minus a as x approaches a. Use the quotient rule to take the limit of the total quotient, then the two denominators will cancel, leaving us with the limit of f of x minus f of a over g of x minus g of a as x approaches a. Since f of a and g of a equals 0, they can both be removed from the limit, leaving it equal to the limit of f of x over g of x as x approaches a. Returning to our example we discussed previously, the limit of x cubed minus 2x plus 1 over x minus 1 as x approaches 1. First, we let f of x equal x cubed minus 2x plus 1, and let g of x equal x minus 1. That would make f prime of x equal to 3x squared minus 2, and g prime of x equal to 1. Therefore, the initial limit is equal to the limit of 3x squared minus 2 over 1 as x approaches 1. Take this limit, and you get your final answer. The limit equals 1. In cases where the first derivative results in the indeterminate form 0 over 0, we can use the same proof to establish that the second derivative will also equal. As an example, let's take the limit of e to the x minus 1 over x squared as x approaches 0. Using substitution, we arrive at the indeterminate form 0 over 0. When we take the first derivative, we get the limit of e to the x minus 1 over 2x as x approaches 0. Again, we use substitution to get the indeterminate form 0 over 0. When we take the second derivative, we get the limit of e to the x over 2 as x approaches 0. This one yields to the correct solution 1/2. L'Hopital's rule also applies to indeterminate forms where initial substitution results in infinity over infinity. As an example, let's look at the limit of the natural log of x over x squared as x approaches infinity. Substitution leads us to the indeterminate form infinity over infinity. When we apply L'Hopital's rule and take the first derivative, we get the limit of 1 over x over 2x as x approaches infinity. We can simplify this to get the limit of 1 over 2x squared as x approaches infinity. Taking this limit results in 1 over infinity, which equals 0. L'Hopital's rule is designed to be applied to indeterminate forms 0 over 0 and infinity over infinity. To apply this rule to other forms, the limit must be rewritten into one of the two desired forms. For example, let's take the limit of x times cosecant x as x approaches 0. Since the limit of x as x approaches 0 is 0, and the limit of cosecant x as x approaches 0 is infinity, the limit in its current form cannot be taken directly. However, if we use our trigonometric identities, we can rewrite the limit as x over sine x as x approaches 0. The limit is now a desired indeterminate form 0 over 0. When we apply L'Hopital's rule, we get the limit of 1 over cosine x as x approaches 0, which, when substituting, comes out as 1 over 1, or 1. For limits in the form infinity minus infinity, it is also usually possible to rewrite the limit as 0 over 0 or infinity over infinity using algebra and trigonometry techniques. As an example, let's take the limit of x minus the square root of x squared minus 4x as x approaches infinity. This limit is indeterminate to infinity minus infinity. First, we factor in x out of the radical, then factor it out of the parentheses. Then rewrite the x as a denominator 1 over x. Now we have the limit of 1 minus the square root of 1 minus 4 over x all over 1 over x as x approaches infinity. To simplify our limit, let t equal 1 over x. Now the limit can be rewritten as 1 minus the square root of 1 minus 4t over t as t approaches 0 from the right. Now the limit is in the indeterminate form 0 over 0. Apply L'Hopital's rule. The first derivative gives us the limit of 4 over 2 times the square root of 1 minus 4t all over 1 as t approaches 0 from the right. This limit can be taken to arrive at 4 over 2 or 2 as the final answer. The three indeterminate exponent forms arise from the limit of f of x to the g of x as x approaches a. These forms can generally be solved using the relationship between ln x and e to the x, which is a to the x equals e to the natural log of a to the x, which equals e to the x natural log of a. From this, we can rewrite the limit as e to the g of x times the natural log of f of x as x approaches a. Next, we analyze e to the l, where l is the limit of g of x natural log of f of x as x approaches a. From here, L'Hopital's rule may now be used to evaluate a limit in either of the indeterminate forms 0 over 0 or infinity over infinity. As an example, let's solve the limit of x to the x as x approaches 0 from the right. X to the x can be rewritten as e to the x natural log of x. Then we evaluate L as the limit of x natural log of x as x approaches 0 from the right. X natural log of x can be rewritten as natural log of x over 1 over x. Now we use L'Hopital's rule and take the first derivative to get the limit of 1 over x over negative 1 over x squared as x approaches 0 from the right. We can simplify this limit to negative x as x approaches 0 from the right, which is 0. Next, we re-exponentiate the limit. The limit of x to the x as x approaches 0 from the right equals e to the l, or e to the 0, which equals 1. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.